This is the video on section 5.1 where I'm going to introduce to you some basic concepts about angles. We're going to go pretty quickly through this. So let's look at some basic terminology. In trig, an angle is simply two rays and a common endpoint. Those two rays are going to be, each one is going to be called a side of the angle, and the common endpoint is going to be called the vertex of the angle. The measure of an angle is determined by rotating a ray starting at one side of the angle. This guy is called the initial side. And we're going to rotate to the terminal side. You see a picture here that shows you start at the initial side and you move to the terminal side. Frequently, most often, the initial side is going to be on the positive x-axis. A clockwise rotation is going to give you a positive angle measure, while a counterclockwise rotation gives a positive measure, and a clockwise rotation gives a negative angle or a negative measure. All right, if you'll go down to the types of angles that you have, if your angle is between 0 and 90 degrees, it's called an acute angle. You probably learned this in high school geometry, so I'll move pretty quickly through it. An angle that's exactly 90 degrees is a right angle. If my angle is more than 90 but less than 180, it's called obtuse. And lastly, if my angle is exactly 180 degrees, it's going to be called a straight angle. If the sum of the measures is equal to 90 degrees, we say that those angles are complementary, or you could say that the angles are complements of each other. That's two different ways to say the same thing. If I have two angles whose sum is 180 degrees, they are supplementary, or you can say that those angles are supplements of each other. Finding a complement and a supplement. So in this example, we're asked to find the complement and the supplement of a 55-degree angle. So my complement is going to be found by taking 90 degrees minus 55 degrees, which will give me 35 degrees. And my supplement will be by taking 180 degrees minus 55 degrees, which will give us 125 degrees. The reflection question here, if you have an angle, how many degrees does the supplement differ from the complement? Always 90 degrees. All right, sometimes you're given a figure and you have to find the two angles. Maybe they are complementary or they are supplementary angles. So let's look first of all at the part A. Notice that my two angles are adding together to give me a right angle. So these two are complements of each other. And so the first thing that we're going to do is set up an equation. We'll take the small angle plus the small angle is equal to 90 degrees. Definition of complementary. Combine like terms, divide by 5, and you have that your x value is 18. Now, let's come back up. I wasn't asked for the x value. I was asked to find the measure of each marked angle in the figure. So, yes, my x value is 18, but I need to go a little further to find what those two angles are. So, the 2x angle is 36 degrees. The 3x angle is 44 degrees. Same concept for part B. The difference is that now these two angles are supplements. They form a straight angle. So we'll set up an equation, 7x plus 2x equals 180. Combine like terms, divide by 9, and we'll get that our x value is 20 degrees. So the larger of the two angles is going to be 140 degrees. The smaller of the two angles will be 40 degrees. All right, now let's talk about breaking degrees into pieces. So a degree can be broken into a smaller portion, and these portions are going to be called minutes. Notice that the symbol for minutes here is a single apostrophe, and seconds, which is a double apostrophe, frequently referred to as DMS, standing for degrees, minutes, and seconds. 1 degree is the same thing as 60 minutes, and we would write that as 60 with a single apostrophe. 1 minute is the same thing as, just like in time, 60 seconds, which is shown by 60 with the double apostrophe. Now, the way that I have you working these, there is a mathematical way that you can do this, but I just have you using the calculator on this particular section. So I'll give you the answers, but I want to show you on the calculator how to do that. So 105 degrees, 20 minutes, and 32 seconds converted to decimal degrees. First thing, before I even plug anything into a calculator, I know it's going to be 105 point something degrees because I have 105 whole degrees plus a little bit more. So the answer here is going to be 105.342 repeating, but my directions said to round to the nearest thousandth. So this is going to be 105.342 degrees. Going backwards, converting 85.263 degrees to DMS. First thing, I automatically know this is going to be 85 degrees, some kind of minutes and some kind of seconds. But the 85 degree part I know for certain. And sure enough, it ends up being 85 degrees, 15 minutes, and 45 seconds. Now, what I want you to do is I'm going to show you the keystrokes on this, but I want you to pause because I just gave you some screenshots. Pause the video and work through both of these examples on your calculator. So here's the keystrokes for the, let me zoom out just a little bit. Here's the keystrokes for the first example. So go ahead and pause the video and work through each of these. All right, so now that you're back, here is the keystrokes for the second example for part B. So pause the video and work through this one as well. All right, if you have any questions on that, please just let me know. Now let's go back up to an angle in standard position. An angle that's in standard position has the vertex at the origin. So my vertex would be right there at 0, 0. And the initial side is going to be on the positive x-axis. So my angle would look something like this. The initial side is on the positive x-axis. This is an angle in standard position. Now, notice I didn't draw the whole angle. In order to get the other side of the angle, I would need to rotate that initial side and stop at a terminal side. Quadrantal angles are angles in standard position, first of all, where the terminal side lies on either the x-axis or the y-axis. So examples of this would be 90 degrees, 180 degrees, etc. These are all quadrantal angles. Again, those are those calculator keystrokes that I walked you through. All right, now let's talk about coterminal angles. Coterminal angles, let's look at an example of coterminal angles. 60 degrees and 420 degrees have the same initial side and the same terminal side, but they're completely different amounts of rotation. So take a look. This turquoise colored angle is a 60-degree angle starting at the initial side and stopping at that blue terminal side. But notice the red that indicates the 420 degrees. It goes all the way around plus a little bit more. But they do stop at the same place, which is why they're called coterminal angles. Their measures are going to differ by multiples of 360 degrees. So 360 degrees or 720 degrees, etc. Here's another example. Notice the 110-degree angle started at the initial side and the terminal side stopped in quadrant 2. Whereas 830, it went around the circle, it went around again, and finally on the third time around, it stopped at that same place that my 110 stopped. So this is these are coterminal because they have the same initial side and they have the same terminal side, but their angles are actually differing in measure. So let's work some examples dealing with coterminal angles. Notice the directions. Find the angle of least positive measure that is coterminal with each angle. All right, so 1,106 degrees. Well, the first thing is in order to get the angle of least positive measure, I need to subtract whole entire circles. And a whole entire circle is worth 360 degrees. So I'm going to take 1106 and I'm going to subtract 3 whole entire circles. Subtract 360, subtract 360, subtract 360. When I do this, I'm going to get 26 degrees. So 1106 degrees is coterminal with 26 degrees. For part B, what I'm going to do is instead of subtracting, I'm going to add, because this asks me for the least positive measure. I'm already sitting at a negative angle. So I'm going to take my negative 150 and I'm going to add 1 whole circle to it. And I'm going to get 210 degrees. Part C, negative 603 degrees. So I will add a whole circle, but that's not enough. So I'm going to add another whole circle. So notice I'm adding 2 whole circles to this. And when I do that, I'm going to get 117 degrees. So negative 603 degrees and 117 degrees have the same initial side and the same terminal side. Just a reflection here, it asked me to do 2 different things. The first thing is give 4 examples of angles that are coterminal with 60 degrees. Now, it doesn't say they have to be positive or negative, so I just happened to do 2 positives and 2 negatives. But you could have done 4 positives if you really wanted to. And so what I did was I took my 60 degrees and I added a whole circle to get 420. I added another whole circle to get 780. Then I went back to the 60 and subtracted a whole circle and got negative 300. Subtracted another whole circle to get negative 660. So what we have here is all 4 of these angles are coterminal with 60 degrees. The second part of this reflection question says to give 4 examples of coterminal quadrantal angles. So remember, quadrantal angles are angles whose terminal side lands on an axis. Now what I did was I just chose my 90-degree spot. And 90 degrees, if I add or subtract whole circles, I got 3 more coterminal angles of negative 270, 450 degrees, and negative 630 degrees. All right, example 6 is kind of an interesting little question here. It says a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in only 5 seconds? So the first thing that I did was I set up a fraction. I said, well, 270 revolutions per minute is going to look like 270 revolutions for every 1 minute. So per 1 minute or over 1 minute. And then what I did was I said, well, I don't want to be talking about minutes. I want to be talking about seconds. So I left the numerator alone, but the denominator, instead of writing 1 minute, I wrote its equivalent, which is 60 seconds. Now, I don't want to be working with 60 seconds. I want to be working with 5 seconds. So what I did next was I just simply divided both the top and the bottom by 12. And the reason I did that was because that would give me 5 seconds in the denominator. So 60 seconds divided by 12 is 5 seconds. But what you do to the top or bottom, you have to also do to the top. So I got 22.5 revolutions in every 5 seconds. And then I just reworded it. So the wheel moves 22.5. I'm sorry, I should have put revolutions, not degrees. In 5 seconds. So I will fix that. So 22.5 revolutions in 5 seconds. All right.